and welcome to example 2. Rewrite the equation y equals x squared plus 12x plus 3 in vertex form. We're going to do it two ways. First we'll do it by completing the square, and then we'll do it graphically. So by completing the square, we're looking for perfect squares because you know your target is vertex form. Y minus k is a times x minus h squared. We are looking for a perfect square over on this side, and so we need to get a perfect square. We'll complete the square to do that. First off, you notice that this x squared plus 12x plus 3 is not a perfect square. So the task is to make it into a perfect square. First step, we'll take the 3 away. Move it over to the other side. You've got y minus 3 equals x squared plus 12x. And now the question is to do just like we did in example 1 and say what makes this a perfect square. Well, we've got x squared plus 12x. To get a perfect square, we need x squared plus 12x plus 36. And if we're going to add 36 to that side, to the right-hand side, we best add 36 to the left-hand side as well. And now it's just a matter of simplifying, and we have the equation in vertex form. On the left-hand side, you simplify y plus 33. On the right-hand side, you simplify x plus 6, quantity squared, and we've got it in vertex form with a vertex of negative 6, negative 3. And when I say negative 3, I mean negative 33. Negative 6, negative 33. There's vertex form there. Now, the graph version. Just completed the completing the square version. Now we'll do the graph version. You're welcome to do whichever one you choose. In this case, we'll take the equation x squared plus 12x plus 3. We'll graph it. I'm going to choose a standard window to start, not having any additional information, guessing that that's an okay one. And I'm noticing that the vertex of this parabola is way down low. So I'm going to go to y equals and move the y minimum. I'm going to make it negative 50 and see what that does. Change the graph. Aha! Now I see the vertex of the parabola. The vertex of the parabola is right there, and I need to find it. It's a minimum value. Minimum 3. My lower bound is someplace to the left here. To find a minimum, remember I put the lower bound on the left, the upper bound on the right, and I have the minimum at negative 6, negative 33. A minimum at negative 6, negative 33 is a good thing. It tells me what the vertex is. So in this case, we're sort of going the opposite direction. We've got the vertex first, and we're using that to write it in vertex form. If the vertex is indeed negative 6, negative 33, the equation becomes y plus 33 equals x plus 6 squared. The value of a is just 1, the same way as it was in the original equation. So there you go. Rewriting in vertex form, converting from standard to vertex form, and finding a vertex by two different methods. Enjoy.